Then the definition of a base, how we define a base, a substance which accept proton or donate OH ion. Proton means H plus or donate OH ion, we call that substance as a base. So acids are proton donors, bases are proton acceptor or OH ion donors or hydroxide ion donors. What is the meaning? Like example, you have NaOH, sodium hydroxide. What are the ions this sodium hydroxide will dissociate? You have NaOH, sodium hydroxide. What are the ions it will dissociate into?
Na plus and OH minus.
So Na plus and OH minus. So when it is dissociating or break down into Na plus and OH minus, what we call, as you can see, this substance is giving OH ion. It's NaOH, it gives out OH ion in the solution. So whenever a substance is donating OH ion, what we call that substance? We call that substance as a base. So definition of the base, bases are OH ion donor. This is one. Or this is a second definition, it accept proton. So I will repeat the same example, like it was NH3 was reacting with HCl. When NH3 was reacting with HCl, what it become? It become NH4 and Cl minus. So when you apply the definition here, so when you apply the definition here, NH3, so first it is NH3, then it become NH4. So if NH3 become or changes into NH4, so what happened? It accept proton or donate proton?
It
NH3,
accepts.
NH3 become NH4. So hydrogen number or proton number increase. So we call that as accept proton. So if a substance accept proton, what we call that substance? We also call that substance as base. So base definition, two ways you can define, because the first definition and both definitions cannot be applied for a same substance. So it depends from substance to substance. So if a substance, if it accept proton, we call that as a base, or it donate hydroxide ion, we also call that as base. So acid are proton donors, bases are proton acceptors or hydroxide ion donors. Same way, if I write CaOH and if it dissociate partially into Ca plus 2 and OH hydroxide ion, 2 hydroxide ions. So you can see first it is calcium hydroxide, but it gives 2 hydroxide ion. If a substance give hydroxide ion or donate hydroxide ion, what we call that substance? We call that substance as base. So simple definition of the base, bases are proton acceptor. So acids are proton donors and bases are proton acceptor, or bases can also give OH ion. If I write CaSO4, calcium sulfate, and it break down into calcium ion and sulfate ion. Is this a base? Calcium sulfate dissociate into calcium +2 ion and sulfate -2. Is this a base?
No.
It is not a base because it does not give hydroxide ion, or it is not accepting proton. So it does, both definitions cannot be applied. CaSO4, it breaks down into Ca plus and SO4 minus. So it does not accept proton, or it does not give hydroxide ion. So it is not a base. To be a base, it should either accept proton or give hydroxide ion. Is it clear?
Yes, sir.
Take the screenshot, then I'll give more examples. So it is not an acid, not a base. Calcium sulfate is neither acid or base. Actually, it's a salt. Calcium sulfate is not donating proton, so it's not an acid. It is not accepting proton, so it is not a base. So what is this calcium sulfate? It is not an acid, not a base. Actually, it is a salt. Another example, if you have sodium oxide, you add water, and it becomes sodium hydroxide. So sodium oxide, you mix in water and it becomes sodium hydroxide. Equation I did not balance because I'm just explaining the idea. So if a question is whether this sodium oxide is acid or a base, so you have to apply a definition. So it is sodium oxide, then it becomes sodium hydroxide. So first there was no hydrogen, then there is hydrogen inside. So what happened? It accept hydrogen or donate hydrogen?
It accepted hydrogen.
So it accept hydrogen. Accept means take. So if it accept hydrogen or take hydrogen, what is this substance? Acid or base? If a substance accept hydrogen, what we call? We call that substance as a base. How you identify? First there was no hydrogen, then there is one hydrogen here. So if a substance accept proton, or if the hydrogen number increase in the substance, we call that substance as a base. So sodium oxide is a base. Same way, potassium oxide, you add water or you mix in water and it form potassium hydroxide, or it turn into potassium hydroxide. So it will form potassium hydroxide. So if it is potassium oxide, originally there was potassium oxide and then it turned into potassium hydroxide. So what we call that as base. Is it clear, the concept of the base? So you will find a question in which you have to identify a substance, whether a substance is acid or a base. I will give examples also. I will share you some questions related to this topic. But the main thing is first understanding of the concept. What is acid? So acid is a substance which donate hydrogen ion, and base is a substance which accept hydrogen ion or donate OH ion.
Sir, acids also accept OH ions, right?
Yeah, but the second definition is not valid for almost, like, it's rarely it happens. That's why the first definition applied for all the acids can be applied on all acids. That's why the second definition does not make difference. But you can define in the other way.
Okay, sir.
Then alkali, the base. And what is alkali? Soluble bases is known as alkali. Means the base which can dissolve in water called alkali. So example, we have magnesium hydroxide, okay? Say calcium hydroxide, or start with sodium hydroxide is there. And we have magnesium hydroxide. So because there is hydroxide ion, so if there is a hydroxide ion, what I call this substance, this will be a base. Magnesium hydroxide, so it contains hydroxide. What is this substance? This is also a base. So both substances are base. But what happened, and both are solid, like this is also solid, magnesium hydroxide is also solid. But what happened if I add this to a water? When I add this solid to water and this solid dissolve completely, so if base can dissolve in water, that base is also known as alkali. So I can say sodium hydroxide is a base, or I can also say sodium hydroxide is an alkali. So if I'm able to dissolve the base in water, I will simply say, I can also say this base as alkali. But what happens if I have a container, I have a base, and I fill the container with water? So I fill this container with water and I add this base to the water. But what I observe that this base does not dissolve at all. It remain unchanged. So if it does not dissolve at all or remain unchanged or insoluble, so I will not say it is a base. I will not say it's an alkali. I will simply say it is a base, but it is not alkali. So simple difference between the alkali and the base, the soluble bases are known as alkali. So all alkalis are bases, but all bases are not alkali. Is it clear, the concept? Like if I make a Venn diagram, in mathematics you used to do this Venn diagram. So if this is for base, this whole is base, the part of the base which can dissolve in water, what we call, we can also say base, or we can also say it is alkali. So soluble bases, the bases which can dissolve in water, are known as alkali. If bases are insoluble in water, we simply call them as base, but we don't say it as alkali. So all alkalis are bases, but all bases are not alkalis. Is this clear? The difference between the base and the alkali?
Yes.
Take the
Sir,
screenshot.
what if I dissolve the basic oxides?
If basic oxide also dissolve, then you also call that as alkali. Like it will form an alkali. Because when you, for example, if you have sodium oxide, so sodium oxide dissolve in water and it will form sodium hydroxide. So sodium hydroxide is an alkali.
It's
Sodium
like
oxide,
when I dissolve sodium hydroxide in water,
yeah,
it dissociates into Na plus and OH hydroxide ions,
right,
right?
right.
So if I dissolve sodium oxide, I already get sodium hydroxide as my product. So will the product itself be dissociated when it's in
Yeah,
water?
it will dissociate. It will, like sodium oxide mixed with water, it will result in a formation of sodium hydroxide, and that sodium hydroxide actually dissociate in water. That's why we call that as alkali. Is it clear?
And magnesium oxide as well. It's a base, but it's insoluble.
It's insoluble.
Okay, sir. Thank you.
Okay. So if the basic idea is, so you don't say that as a alkali. If it does not dissolve, you don't say alkali, you simply say base. But if it dissolve, you call that as alkali. Then these alkalis, as you know, alkali means the soluble bases are known as alkalis. So alkali can be strong alkali, it can be weak alkali. Strong alkali means, it the same definition, it will ionize or dissociate completely. So ionize or dissociate completely, we call strong. But if it is ionized or dissociate partially, we call that as weak alkali. So strong alkalis, they have more ions. Weak alkalis have few ions. And it's the same concept. Like example, if I say um, sodium hydroxide. Sodium hydroxide is a strong alkali. Why we call that as a strong alkali? Because if you have sodium hydroxide and you have, say, 100 molecules, so if you have 100 molecules of sodium hydroxide, when you add water, out of 100 molecule, almost 99 of them will break into ions. So 99 of them will break into ions. If 99 of them will break into ions, so what does it mean? It contains more ions or more OH ions. We call that as strong alkali. But weak alkali, like example, calcium hydroxide. Calcium hydroxide is partially soluble. So partially soluble means very small amount will dissolve. So if you have 100 molecules of calcium hydroxide, when you add water, it will dissociate into calcium ion and two hydroxide ions. But still the number of the ions in which it will dissociate, maybe two ions, two of them out of 100, two of them will break into ion and remaining will remain, others will remain as a molecule. So it will have few hydroxide ions or OH ions in the solution. And how we can find a difference between a strong and a weak alkali. So we'll take a container. We will fill with, we don't know whether it's a strong or a weak. So what we'll do, we'll fill a container and we'll add an alkali, which we want to identify whether it's a strong or a weak. And we will pass the current, do electrolysis. So as we pass the current, if it's a strong alkali, it contains more ions. Greater number of ions are there within the electrolyte or solution. So as there are greater number of ions within the electrolyte or solution, so when we pass the current, what we'll observe? We'll observe that the lamp will give a high intensity, or it will be bright. But the same way, if we are passing a current through a weak alkali contain ions, but few ions are there, more molecules and few ions. So the brightness will be low or the lamp will be dim. So using electrolysis, you can also identify if you have an alkali, you pass the current. If it allow greater amount of current to pass, it will be much brighter. Shows that it's a strong alkali. If it's dim, means it is a weak alkali. Is this clear? The concept of alkali, the strong and the weak?
Sir, I have a question. Sir, like,
Yes.
can we measure like the strength? So we say that there are more OH negative ions. So
Can
there will
we?
be less.
Yeah. There.
So we say that there are more OH negative ions.
Hmm.
So we can say that there are less H plus ions in the alkali.
Yeah, in the alkali, you can mention compared to when we compare hydrogen ion with hydroxide ion in alkali, you will have more OH ion as compared to H ions. That's true. So what? How you want to make a difference? Like what? Can you repeat your question? Like the second
So
part of
like,
your.
yeah.
Hmm?
So we have more OH negative ions in the alkalis.
In alkali,
So
yes.
yeah, so there will be like eventually, like, because there are more OH negative, there will be less H plus ions like floating around
Yes.
in the solution. So we can say that they have just less H plus ions.
Yes, you can, or in short, because there are hydroxide ions are there and H plus ions are there, but in short, like because you are using a common term ions, so you can simply say few ions are there instead of specify like which ion is more and which ion is less. I got your point. You're saying like because hydroxide ions are less, so H plus ions are also few H plus ions are there. You can mention that, but the thing is, instead of specify which ion is less or more, you can just generalize that, mention that it contains few ions in the solution or electrolytes in the electrolyte. Is it clear?
Yes, yeah, it's like not that polar, we can say.
Yeah, not that polar. Or that's correct. So this is one of the way to identify whether an acid is alkali is a strong or weak by passing the current. Then there is a second way, as we discussed, we can measure the pH. The pH is power of hydrogen ions, and pH is directly proportional to hydroxide ions. If there are more hydroxide ions in the solution, then the pH of a solution will be higher. If there are few hydroxide ions in the solution, then the pH will be lower. But so strong alkalis have Yes, you can take the screenshot. So strong alkalis, if an alkali is strong, it contain more OH ions, so it will have higher pH, and weak alkalis contain few OH ions, so they will have lower pH. But all the alkalis have pH more than 7. So example, you have two alkalis, alkali A having a pH of 10, and you have alkali B which is having pH of 13. Which alkali is strong here?
Alkali B.
So alkali B is stronger because higher pH. So this is a strong alkali. And pH 10 means it will be weak alkali. So for alkalis, the alkali which is having a stronger, the alkali which is having a higher pH will be stronger as compared to alkali which is having a lower pH. So you can also use the pH of a solution to indicate what kind of solution is this, or you can use electrolysis to identify strong and weak alkali. Take the screenshot. I'll give another example. So the pH scale can be used to identify the nature of the solution. So the variation of this scale, 0 to, this is less than 7 and this one is more than 7. So less than 7 is acidic, more than 7 is basic or alkaline, and equal to 7 is neutral. And if we move toward this side, if we move, so what happened? The acidity will increase. It will become more acidic or strong acidic solution. And if we move towards right hand side, so what will happen? It will become more basic. So example, I have 4 bottles which contain 4 different substances, and I want to identify the nature of the substance. And I know the pH of each The pH for this one is 2, 5, 7, 11, and 14. This is substance A, B, C, D, and E. Now the question is, which substance is neutral?
Substance C.
So substance C is a neutral because it's having a pH 7. So C is a neutral solution. Which substance is strong acid?
Substance A.
So substance A, because it's having a lower pH, so the substance which is having a lower pH is a strong acid. Which substances are acids?
A and B.
So A and B are the acids. And which substance is a weak base or weak alkali?
D.
So which substance is a weak alkali? D is a weak alkali. Is this clear? The concept of acid. Now, which substance contain greater number of hydrogen ion?
Substance A.
So more hydrogen ion, it means it's a strong acid. So strong acid, so A is the right answer. Which substance contain more hydroxide ions, OH
E.
ions? So substance E contain greater number of hydroxide ions. So this is the main concept we identify, like acid is a substance which donate proton, base is a substance which accept proton, or it will donate hydroxide or OHI. Is this clear? Take the screenshot.
Sir,
Yes.
sir, I have a question. So,
Yes.
so before 7 p, for the pH of 7, there will be no any hydroxide ions. Like in
no,
the
there will be hydroxide ions, but the thing is, compared to hydroxide ion, basically these substances show their nature when they are in aqueous solution. Like example, I got your question.
Yeah, okay.
Look, the example, what happened? HCl is a gas at room temperature. So HCl is called a hydrogen chloride gas. But to know the nature of a substance, we should make an aqueous solution. We should dissolve them in water. So water itself, example, you have a container, okay, and this container is filled with water. So what is water? Water is H2O. And what does it mean, H2O? It means it contain water itself have hydrogen ion and hydroxide ion. Both ions are there, but as a molecule, it's H2O. So it can have hydrogen ion and hydroxide ion. Example, the water is having a pH 7. It's a distilled water, because water can be acidic or alkaline depending on the amount. For example, this water is a neutral water, which is why it's neutral water, because it contains equal number of hydrogen ion and hydroxide ion. Now what happened? I have a hydrogen chloride gas and I add this hydrogen chloride gas or pass this hydrogen chloride gas through water. So when I pass this hydrogen chloride gas through water, so what this hydrogen chloride gas will dissociate? It will dissociate into H plus and Cl minus. So what happened now? Now the balance is shifted. You can see now in the solution, you have more hydrogen ion and few hydroxide ion. So if in the solution you have more hydrogen ion, and few hydroxide ion. So what will be the nature of this solution now? It will turn into acidic. Why it will turn into acidic? Because it is now having more hydrogen ion. So the substance, the water will turn acidic or alkaline, or a substance show its nature when they are in a solution, or when they make, or we make an aqueous solution. Is this clear?
Yes,
So
sir. Thank
there
you.
are hydroxide ion as well, but because the number of hydrogen ions are more as you add hydrogen chloride gas, that is why we say it is acidic, or hydrogen chloride, or hydrochloric acid, because it donate hydrogen ion and it increase the number of hydrogen ion in the electrolyte or in the
So like
solution.
in
Yeah.
bases, their compound, like their structure itself, like the NaOH, they have in their compound a problem that like they have like the substance to form more OH negative in the solution.
Yeah, they remain as a molecule. You you want a
If they
different.
dissociate,
Yeah, if they
if they
dissolve.
dissociate,
Yeah,
yeah. So they will form like more OH negative ions.
right.
Yeah. Thank you,
So
sir.
basically, if it dissolve, we call alkali. If it does not dissolve, we don't simply say it's a base. Then there is also another way to identify the nature of a solution. We can also use indicators. We can measure pH. We can pass the current. pH meter is used to measure the pH of a solution. So we can also use indicator. Indicator is used to find nature of the solution. So how they show the nature of a solution? Indicators show different colors in different mediums or different solution. Nature of solution. And you have to learn specific indicators. Less than a minute left. So next session, I will share a link with you and I will explain this indicator in the next part. So indicators are a substance which can be used to identify the nature of a solution. Indicators show different colors according to nature of a solution. You have to learn the name of different indicators.